Alright guys, so I put together a little bit of a review for the test. I know we already talked about the practice test and everything, but I figured that this might be a little bit extra, something that you guys could watch. So the first few topics are all from section 3.1. We have the elimination method, the substitution method, and the graphing on your calculator method. So we're going to take a look. We're looking at the section by section review. This is page 207. Problem number 11. So I'm going to write the problem down. What we're going to do is we're going to do it by elimination and by substitution and by graphing. I figured it would be a good way to show you, first of all the different methods that you're supposed to know how to do for the test, and also just to show you that no matter what method you're using, as long as you're doing it accurately, of course, you will come up with the same answer. So this is number 11. We've got 3x plus 4y equals 8, and then the second equation is x minus 3y equals negative 6. So like I said, I want to do it doing 3 different methods. The first method we did was just by graphing on the calculator. So let's do that. So whenever we do calculator stuff, we want a new document, or you could always add a new page to an old document. We're going to do a graph page. So first of all, when we're in standard form, which is obviously what we're in right here, you might as well just plug your function right into the calculator in standard form. Don't fear the standard form. So what you do is you push the menu key over on the right hand side, and then you can do the graph entry, equation, line, and then there's your standard form right there, number 3. Okay, so then you can just enter this right in. So we've got 3x, and then hit tab, plus 4y, hit tab again, equals 8. So that's our first equation. There it is. The graph looks like that. We can look at its y-intercept, its x-intercept, its slope, and then hit tab and we can enter in another one. So this one's just x, which means we technically have a 1 in front of the x. Don't forget about that. Hit tab, and then we have minus 3y, so we're going to put a negative 3 equals a negative 6. Okay, so hit enter again. There are 2 equations. This one, it's pretty clear to see where they intersect because they're going to intersect right here on the y-axis. But what I want to do is remind you guys how to put those grids on, because most of the time you will not be intersecting right on one of the axes, and so you'll need the grids. So hit the menu key here over on the right-hand side. We're going to go to the menu for View, down to Grid, and then Lined Grid. Okay, so there we go. Now it looks just like graph paper, so we can see that it is this point right about here where your lines intersect each other. So here's the origin right here. So we are up 2 units. So that is the point 0, 2. So by graphing, we found 0, 2. On your test, I will explicitly tell you what method I want you to use. So next, let's do the substitution method. So this we got by graphing. So really, there's no work required when you do this on the test. All you have to do is write down the ordered pair. So now let's do this by substitution. So back up here, what we want to do for the substitution method is you want to find the variable that is closest to being by itself. So we're going to take this x right here, and we want to get it by itself. That's the first step of the substitution method. So we're going to add 3y to both sides. So we end up with x equals negative 6 plus 3y. So that is an expression for x. So the substitution method says, well, this equation tells us that x is the same as negative 6 plus 3y, so why wouldn't this x be the same as negative 6 plus 3y? So that's what we do, is we literally substitute in that expression for the other value of x. So we take this first equation and rewrite it. So 3, and then instead of an x, we are going to plug in that negative 6 plus 3y, and then continue on the equation. Plus 4y equals 8. So you can see it's the exact same as this equation right here, except I replaced the x with this expression right there. Okay, so now we simplify up. So distribute 3. I have a negative 18 plus 9y plus 4y equals 8. Next thing on the left-hand side is I want to combine up like terms. So I have a 9y and a 4y that I could combine up to give me 13y. Then to get the y's by itself, I'm going to add 18 to both sides. Okay, so the 13y is by itself on the left, and then I get 26 on the right. And then to get the y totally by itself, I'm going to divide both sides by 13. All right, so 13's cancel, so I end up with y equals 2. That is my final answer for y. Remember, that's only half of it. It needs to be an ordered pair. So I'm going to take this value of y, and I am going to plug it in right there for y, and then I can solve for x. So x equals -6, and then plus 3, I'm going to replace the y with a 2, and then I can simplify this up. So -6 plus, of course, 3 times 2 is 6. -6 and +6 gives me 0. So my x value is 0, my y value is 2. Put that in ordered pair, x first, then y. So that's the exact same answer that we came up with the graphing method, which is good, means we did it right. So the last thing we're going to do is do the elimination method on the exact same problem. So I'm going to rewrite 3x plus 4y equals 8, and then x minus 3y equals -6. So remember the way the elimination method works is we are trying to get one of our variables to cancel out. So we might have to multiply one of the equations or something like that, possibly both of the equations. So if we look at the x's first, we've got a 3x, here we've got just an x. We want to get them to be opposite terms. You know, a positive 3x and a negative 3x, for instance, and then they would cancel out. So the way to get this to be a negative 3x is to multiply it by a -3. But I can't just multiply one of the terms by a -3, so I have to multiply everything by a -3. I could have also gotten the y's to work, but 4 and 3 aren't multiples of each other, so I would have to get them both to be 12. So I could have multiplied this by 3 to give me a positive 12y, and I could have multiplied this by 4 to give me a negative 12y, then they would have canceled, but this one can be done in one step only, so it's a little bit easier to work with the x's, but again, you absolutely could have worked with the y's. So let's rewrite. We've got 3x plus 4y equals 8, and then if we multiply every single one of these terms by a -3, we get -3x. This would be a positive 9y, because a negative times a negative, and then equals -3 times -6, which gives me 18. Okay, so now I have these opposite x terms. They'll cancel in my first step. Combine these up, I get 13y equals, add these two numbers together, I get 26. Divide both sides by 13 to get the y by itself. You should notice this looks remarkably similar to one of the steps that we had in the substitution method. And then that's half our answer, so we want to take this y equals 2. We could plug it in here. We could plug it in here. We could plug it in here. You've really got any of your options. I like this one because the x is already by itself, so it's a little bit easier, but again, you could plug it into any of them. So we have x and then -3 times 2 equals -6. So x minus 6, if I multiply those out, equals -6. And then the last thing I need to do to get x by itself is to add 6 to both sides. So I end up with x equals 0. So once again, put that ordered pair in order, x and then y, and you can see I get the exact same equation. I'm sorry, the exact same ordered pair all 3 times. So that covers the 3 different methods for you. The next problem I'd like to look at, if you could flip to the next page, we're going to look at page 208, number 27. So the next section, 3.2, it's not that I'm not going to cover section 3.2, it's that 3.2 kind of progresses into 3.3, and so with 3.3 I need to know how to write those equations or those inequalities as well, but it just kind of takes it a step further. So this problem will give us good practice with graphing inequalities. So number 27. A shoe manufacturer makes outdoor shoes and indoor shoes. So let's even just go x and y, because unfortunately we don't want to go o and I, because those would be very weird variables to have, because o looks just like 0. So x would be the outdoor shoes. Y will be, I guess we should say number of. The number of outdoor shoes, the number of indoor shoes. Okay, there's a 2-step process for both kinds of shoes. Each pair of outdoor shoes requires 2 hours in step 1 and 1 hour in step 2. Okay, just writing down all the info that we have here. And produces a profit of $20. $20 profit. And then the next ones, each pair of indoor shoes requires 1 hour in step 1, 3 hours in step 2, and produces a profit of $15. Okay, let's see what other info we have. The company has 40 hours of labor available per day for step 1. Okay, so totals, we've got 40 hours for step 1, we've got 60 hours available for step 2. So that means we've got 40 hours available, 60 hours available. It doesn't necessarily mean we're using every minute of that time. And then what is the manufacturer's maximum profit? That is what we are going to come up with. So first we need to, and now just to warn you guys, and I have told you this already, you won't be coming up with these equations on your own, but this is just good practice. You'll be given the equations directly, and all you have to do is graph, come up with the vertices, and then maximize the profit or whatever other equation. But here we are coming up with the equations on our own. So let's start with an equation that represents this piece right here, that there is a maximum of 40 hours that can be spent on step 1. So we are spending 2 hours in step 1 per pair of outdoor shoes, plus 1 hour in step 1 per pair of indoor shoes, and we have a maximum of 40 hours that we can use. So that has to be less than or equal to 40 hours. We can use the 40 hours, but no more. And then for step 2, we have 1 hour per pair of outdoor shoes, plus 3 hours per pair of indoor shoes, can come out to be no more than $60. I'm sorry, 60 hours. And then the last thing they bring us is the profit. So we're going to have a profit equation. It's going to be an equation of X and Y. We're making $20 per pair of outdoor shoes plus $15 per pair of indoor shoes. So that's going to be the equation that we plug everything into once we're done, once we find the vertices and everything. So on your test, I will give you graph paper. So I'm going to use graph paper right now. We're going to plot these two inequalities, and then we're going to find the vertices, plug them into that equation. Okay, so for this, we've got 40, we've got 60. Let's scale everything maybe by 5. So we're going to scale this by 5. So the x-axis gets scaled by 5, the y-axis gets scaled by 5. Now we can come up with some x and y intercepts. So for this one right here, the x-intercepts, if I plug in 0 for y, that means that I'm making no indoor shoes, I'm making only outdoor shoes. The 40 hours would be spent making 20 pairs of indoor shoes. And then the y-intercept, if I do the same, plug in 0 for x, I would spend 40 hours on those shoes. So let's plot that first one. So my x-intercept is 5, 10, 15, 20. My y-intercept is 5, 10, 15, 20, 25, 30, 35, 40. Okay, so now when I plot this line, remember, the reason I have graph paper is so that I can be perfectly accurate. So I go down 40 units and then over to the right 20 units. So going down 40 units over to the right 20 units reduces down to -2. So I'm going to go down 2 boxes to the right 1, down 2 to the right 1, down 2 to the right 1. You can kind of carry that pattern on. However, I'm not going to go into the negative realm here. So I'm only going to be in the positive realm. So we'll connect those dots, make sure it's perfectly accurate. Again, this one's going to be a segment because I can't have a negative number of outdoor shoes, nor can I have a negative number of indoor shoes. All right, so now let's look at the second one. Second equation right here. If I plug in 0 for y, my x-intercept comes out to be 60. And then if I plug in 0 for x, divide both sides by 3, and my y-intercept comes out to be 20. So let's plot that. So an x-intercept of 60, 10, 15, 20, 30, 40, 50, 55, 60. So we're scaling by 5. So there's an x-intercept of 60, and then we have a y-intercept of 20. So 5, 10, 15, 20. Same thing, we're going to count out that slope. So here I'm going down 20 over to the right 60. So that reduces down to -1 over 3. So I'm going to go down 1 over to the right 3, down 1 over to the right 3, down 1 over to the right 3, down 1 over to the right 3. So I can plot that. There we go. Okay, so now this point right here is an important point to us. So now we got to figure out where everything's shaded. So both of these are less than or equal to. So 0 plus 0 is less than 40. 0 plus 0 is less than 60. So we would shade underneath this line. We would shade underneath this line. And we have to stay in the first quadrant. So it ends up being this region right here. Okay, so now let's come up with our vertices. So we've got the origin as one of our vertices, 0, 0, right there. This one is also one of our vertices, and we know that's on the x-axis. That is 20, 0. We've got this one right here. That is 0, 20. And now this one right here. Now that one is kind of unfortunate because we scaled by 5, so it's actually really tricky to see exactly where that one's going to come out. So let's do a little algebra back on this other page here. We want to see where these two lines are going to intersect each other. All right, so let's take 2x plus y equals 40, because remember that's the equation of the line, and then x plus 3y equals 60. So what I could do is a little bit of an elimination method here. Oops. And I can multiply this whole thing by -2 to get the x's to cancel. So that gives us a -2x and -6y equals a -120. So these x's will cancel. Y and -6y gives me -5y equals 40, and -120 gives me -80. Divide both sides by -5. So my y value is 16. Okay, so yeah, that's a little tricky. So y value of 16, seems like that could be about right, but since I scaled, everything's a little bit thrown off. And I do need to scale because you don't want to count 60 boxes. So then that means that my x value, so if I plug that in here, I have x plus 3 times 16 is 48 equals 60. So if I subtract 48 from both sides, that means I come out with x equals 12. Okay, so the one that I will give you, whoops, there we go. The one that I will give you on the test, unless you scale very strangely, everything should come out nice and neat. So this is 12, 16. All right, so that's where we're at so far. That's the first step, is to plot this system of inequalities, and then we'll come up with all the vertices. Okay, so we've got all the vertices. Now what we want to do is plug them into the equation. So here is my profit equation right here. I'm going to rewrite that on a blank page because everything's getting pretty cluttered. So 20x plus 15y is our profit equation. It's 20x plus 15y, or that. It's 20x plus 15y. I'm going to take these 4 vertices and then plug them in. So first I'm going to plug in the origin. Now the origin means I'm making 0 pairs of outdoor shoes and 0 pairs of indoor shoes. That's not going to make us any money, but we'll plug it in anyways. 0. We kind of knew that was coming. Now let's plug in 0 and 20. This is if I make 0 pairs of outdoor shoes and I make 20 pairs of indoor shoes. So $20 times 0 pairs of outdoor shoes plus $15 times 20 pairs of indoor shoes. That's going to make a profit of $300. Next, let's plug in the 12, 16. $20 times 12 pairs of outdoor shoes plus $15 times 16 pairs of indoor shoes. 20 times 12 is 240. And then 15 times 16 comes out to be also 240. So this makes me $480. So that's looking pretty good. Let's also plug in the last one, the 20, 0. So if I make $20 times $20 or 20 pairs of shoes and then $15 for 0 pairs of shoes, simplify that up. 20 times 20 gives me 400. And then the 15 times 0 gives me 0. So this is the maximum profit. So that's the first thing they ask you is, what is the maximum profit? Well, the profit itself is $480, and you get that from making 12 pairs of outdoor shoes and 16 pairs of indoor shoes. All right, so that is your example for the optimization, the linear programming stuff. The next example I want to look at is number 29, just right below it. So this is, again, still on page 208, number 29. This is one of the systems of 3 equations. So let me write down that system. So we have 2x minus z equals 14. 3x minus y plus 5z equals 0. And we also have 4x plus 2y plus 3z equals a -2. Okay, so 3 different equations. Let's label them. We've got A, B, and C. That way we know exactly what equation we're talking about. So here, one thing I want you to notice is look at part A. Equation A already does not have a value for y, so what we want to do is we want to combine these two up and cancel out the y's. There's no point in canceling out anything else because we kind of get like a free equation right here. This equation is already only in 2 variables. So we're going to combine these two up and get the y's to cancel. So if we look at the y terms, this is a positive 2y. We would need this to be a negative 2y. So let's multiply the whole equation. So we're going to use equation C, and then we're going to multiply equation B by 2. We can combine those up. Alright, so let's write down C exactly the way it is. Remember, I've emphasized to you guys over and over again, do not attempt to do this multiplication and addition in your head. Alright, everything out. So everything here by 2. So 6x minus 2y plus 10z equals still 0. Even if you're multiplying 0 by 2, you still get 0. So I combine these up, I get a 10x. These ones cancel. When I combine these up, I get a 13z. And then I get negative 2. So now this, we're going to call this equation D. And again, we don't need to come up with an equation E, and that's because we already kind of have what would normally be an equation E, and we've got that canceled, or I'm sorry, not the canceled version, but the version that doesn't even have a y to begin with. So we're going to take equation A and equation B and combine them somehow so that we can cancel either the x's or the y's. Alright, I'm sorry, the x's or the z's. So this is just a plain old z, so that is going to be the one that we're going to work with. Or we could work with this one, really, it doesn't matter. This one we'd have to multiply by 13 to get the z's to cancel. This one we'd have to multiply by a negative 5. So that actually might be a little bit easier, just to multiply by negative 5. So I'm going to take equation D, the way it is, and then I'm going to multiply A by a negative 5, and that way I can get those to cancel. Okay, so D stays just the way it is. And then everything here is going to multiply by a negative 5. So 2x times negative 5 gives me a negative 10x, and that's what's going to cancel. Negative z times a negative 5 gives me a positive z. And then 14 times a negative 5, that will give me a negative 70. Okay, so again, you could have done the z's. The z's would be pretty easy to cancel out as well. Alright, so when we combine these up, the x's cancel. I combine 13z with 5z, and I get 18z. Equals a negative 72. So I'm about to get my first variable here. Divide both sides by 18. So z ends up as negative 4. So that's my first value. So then remember, you just kind of trace your way back. So then this one, the z can get plugged into either D or A even if we wanted to. I would say plug it in to A. And then you can solve for x. So 2x minus a negative 4 for z equals 14. Two-step equation, we can subtract the 4 from both sides. We get 2x equals 10. Divide both sides by 2, we'll get x equals 5. So there are 2 of our 3 answers. So now we just need to get y. So I would say go into this middle equation here. See how the y is almost by itself? So take this x right here, plug it in there. Take this z right here and plug it in there. Arrows everywhere. And then we're going to solve for y. So 3x is 3 times 5. That's 15. And then minus y plus 5z is 5 times negative 4. So that's a negative 20. And that's supposed to equal 0. So 15 and a negative 20, that gives me a negative 5. And then minus y equals 0. Just add 5 to both sides and we can solve for y. So negative y, don't forget the negative, equals 5. So that means that y equals negative 5. Alright, so combine them up into an ordered pair. Remember the order does matter. Sorry, ordered triple. 5 for x, negative 5 for y, negative 4 for z, and that would be your final answer. Alright, on to the next page, we're going to look at number 31. This is some matrix stuff. This is now page 209. This is number 31. Some matrix operations. So this I've got 3 and then a big set of parentheses. Okay, so we still follow the order of operations, even though we're working with matrices. Order of operations says that I do what's inside the parentheses first. So inside the parentheses, I've got a matrix plus another matrix. The way that addition works is I just add the corresponding terms, which means it's very important to know that the matrices are the same size first. This is a 2 by 2. 2 rows, 2 columns, and so is this. So that means I can add them together because they are the exact same size. So 3, and then I'm going to combine those up. So I add -2 and +1 to get this first spot. I add 0 and 9 to get this next spot. 6 and -3 gives me +3, and then 8 and -4 gives me +4. Okay, so then the last thing I'm going to do, when I have a 3 on the outside like this, or any number, that's called scalar multiplication, and it means that I'm distributing that 3 to every single one of these values. I'm going to take this matrix and scale it by 3. So 3 times -1 is -3, 3 times 9 is 27, 3 times 3 is 9, and then 3 times 4 is 12. So that's the answer. That's my new matrix that I get from multiplying by a scalar and also adding like terms. So the next one I'm going to do is 35, just down on the bottom of that page. Let's see. Okay, so also on page 209, we're going to do number 35. So this is matrix multiplication. So let's write this out. Okay, so with matrix multiplication, the first thing you need to do is write down the size. So this one has 2 rows, those are the horizontal ones, and 3 columns, those are the vertical ones. So this is a 2 by 3. This one has 3 rows, again, the horizontal ones, and then times 2 columns. So the way we figure out if you can multiply 2 matrices together is you look at these middle numbers. These 2 middle numbers are the same, which means we are allowed to multiply them together. If they are not the same, that doesn't mean you can rearrange the order of the 2 matrices. You leave them just the way they are. It just means that you can't multiply them together. And then the new size is going to be these 2 numbers. So the new size will be a 2 by 2. All right, so let's set that up down here. I'm going to set up a 2 by 2 matrix. There we go. Okay, so we've got 4 spots. So this spot right here, this is the first row, first column. So I'm going to use the first row on the left and the first column on the right. The one on the left always organizes itself in rows. The one on the right always organizes itself in columns. Okay, so rows on the left, columns on the right. And then I pair them up and I multiply them. So -3 times 8 gives me a -24. 0 times -4 gives me 0, so that's a good one. And then 2 times 6 gives me 12. So I'm just multiplying and then adding what I get. This spot right here, this is in the first row, but now I'm in the second column. So I use the first row on the left, and I use the second column this time on the right. So again, pair them off, multiply, add what you get. So -3 times -1 is 3, plus 0 times 3 is 0, and then plus 2 times 7 gives you 14. All right, now I'm down here in the second row. So second row, first column. Second row, first column. So pair them off, multiply, add. 6 times 8 is 48. -1 times -4 is +4. 5 times 6 is 30. Okay, and then my very last spot, this is the second row, second column. So I'm going to use the second row and the second column. So pair them off, multiply, and then add what you get. So 6 times -1, that's a -6. -1 times 3, that's a -3. And then 5 times 7 is 35. Okay, so now all I'm going to do is just add all those terms together. So -24 and +12, that gives me a -12. 3 and 14 gives me 17. 48 and 4 and 30, these two give me 52, and then plus 30 gives me 82. -6 and -3 is a -9, and then combine that with 35, and I end up with 26. Okay, so that is your new matrix. That's what I get after I multiply the 2 of them together. All right, next one that I want to look at is number 39. That is on the next page. Okay, so number 39 is a 3 by 3 matrix. Okay, so let's get a little practice with that. Okay, so when you're doing these 3 by 3 determinants, the first step is to copy over the first 2 columns over to the right. Okay, and then we do these downward diagonals. So you start from the top left, you multiply down the diagonals. You leave your answer down at the bottom here, not at the top. Okay, leave your answer down at the bottom when you're starting from the left corner. So 2 times 2 is 4, times 6 gives us 24. Multiply down this next one. 3 times 4 is 12, times negative 2 is a negative 24. 1 times 0 is 0, times 5 is still 0. Those are the best ones. And then we start from the bottom left corner and multiply up. And when we multiply up, we leave our answers up here. So negative 2 times positive 2 is negative 4, times negative 1 gives us positive 4. Multiply up here. 5 times 4 is 20, times 2 is 40. 6 times 0 is 0, times 3 is still 0. Okay, so the way these work, when I want to come up with the value of my determinant, I add the ones along the bottom. So 24 plus a negative 24 plus 0. So I add them, whether they're positive or negative, I add them. And then I subtract the ones along the top. So minus 4, minus 40, minus 0. So you can go ahead, you can plug that whole strand in. Here's what happens. 24 and negative 24 will cancel. The zeros don't count for anything. And then I have a negative 4 and a negative 40. That gives me a negative 44. Okay, next one is number 40, the very next one on that same page. And this is Cramer's rule, 2 by 2 Cramer's rule. Okay, so the 2 by 2 Cramer's rule, we're supposed to come up with 3 different matrices. So C stands for coefficient. So what I do for this matrix is I just pull the coefficients right off. So 3, negative 1, 5, and 2. Okay, so first I multiply down the diagonal. So 3 times 2 is 6. And then I multiply up from the bottom left corner. 5 times negative 1 is negative 5. So I take the number at the bottom and subtract the number along the top. That gives me 11. Next, I have CX. What CX does is it replaces the X column with these constants. So instead of this column, I'm going to have a 0 and a 22, but everything else stays the same. Okay, so start from the top left corner, multiply down the diagonal, I get 0. And then start from the bottom left corner, multiply up the diagonal, and I get a negative 22. So to get the value of this determinant, I start with the number on the bottom, and then I subtract the number on the top. So this gives me a positive 22. Last one is C sub y. C sub y, I replace the y column with the constants, but everything else stays the same. Okay, so same exact process. Start from the top left, multiply down the diagonal, I get 66. Then start from the bottom left, multiply up the diagonal, I get 0. So I start with the value on the bottom, and I subtract the value on the top, and I get 66. So for my answers, let's write them over here. So the x value is always going to be cx divided by c. Cx is 22 divided by c, which is 11. That gives me a value of 2. The y value is always going to be cy over c. Cy is 66. C is 11. So 66 divided by 11 gives me 6. So my ordered pair is 2 for x, 6 for y, and that is the solution using Cramer's rule. Okay, very last one I want to do is a 3 by 3 Cramer's rule. So let's look at the one just below it, number 41. So let me write down the system first. Okay, so there's your whole system. What we're going to do is we're going to set up the coefficient matrix where we just take all the coefficients off of here. 5 for x, 2 for y, and there is no z. When that happens, I just put a 0. Next equation, 3 for x, 4 for y, 2 for z. Last equation, 7 for x, 3 for y, 4 for z. Okay, let me write down my next matrix. Cx works exactly the way it does in the front. I replace the x column with the constants. So instead of that first column, I'm going to have 4, 6, 29. But the other two stay the same. Okay, next one is C sub y. With C sub y, I replace the y column with the constants, 4, 6, and 29. But everything else stays the same. Okay, and the last of the four is CZ. For CZ, I replace the z column with the constants, but everything else stays the same. Okay, so on your test, I need to see you guys actually writing out these matrices, but then the determinant work you can do on your calculator. Okay, so new calculator page. So I'm just going to add a page to my current document, make it a calculator page. So what I do is you can either type in DET, or you can find it on the matrix menu, open up a set of parentheses. To get the actual matrix, hit our alien symbol key. Remember, that's the weird looking symbols right next to the 9. So hit that menu. You probably have the create your own matrix already highlighted. So select that. 3 by 3 is good. That's your default setting, so just hit OK. And then type in the coefficient matrix. So 5, and then every time you hit tab, it'll arrow over. Okay, so that's our coefficient matrix. We've got that entered in. You just hit enter to get the value. So the value of the coefficient matrix is 54. And then as we go through, we're going to enter the other ones in. We always want to come back to this one, copy, paste it, and then just replace one of the columns. So for my next one, CX, I'm going to arrow up. Whenever you're highlighted, you just hit enter, and that'll paste it. So now I'm just going to arrow over, and I'm going to change just the X column. There we go. So change this to 4. Change this to 6 and 29. So I replace just the X column. So now hit enter. That is 108. Okay, now for CY, again, we want to arrow up all the way up to the original. Hit enter to paste that. And then I want to arrow around and just change my middle row this time, the Y column. So change this to 4, 6, 29. Okay, for that one I get negative 162. Okay, and then my last one right here, again, just like the last one, I'm going to arrow all the way up to my original. Hit enter to paste that, and this time I will just be changing the last column, the Z column, to 4, 6, 29. For that one I get 324. Okay, so this is what I need to see on your test. Matrices written out, but then you can just write the answer. You can do the determinant right on your calculator. And then x, y, z, I have cx over c for x, cy over c for y, and cz over c for z. So I'm going to plug those in. So cx is 108. 108 divided by 54 gives us 2. That's the x value, comma, and the y value. For cy, I got negative 162. Divide that by 54. My y value is negative 3, comma, and then for z, do just, there we go, 324 divided by 54. That gives me 6. Okay, so that would be your final answer, and that is the last one I've got for you. So study hard and good luck.